All right, students, we're going to go ahead and begin lesson 8-7. This lesson deals with the Pythagorean Theorem. And this is one of my all-time favorite things to teach. So there was this dude named Pythagoras, and he was an ancient Greek mathematician, and he figured out this relationship for right triangles. So let's just quickly delve in here. A right triangle is a triangle that has a right angle. Now, the thing about right triangles is that they, because they have that right angle, they also have this longest side known as the hypotenuse. Make sure you're writing this down. The hypotenuse is the longest side. And then there are these two other sides, and they're known as the legs, which is kind of a funny name if you think about it, because you don't necessarily think about your triangle sprouting legs and walking off, right? You don't typically think about that. But, hey, we're going to use the term legs because that's what's commonly accepted. The legs are the things that sprout down from the hypotenuse. And they are the things that meet to form that right angle. Okay, so the legs are the shorter sides. Okay, and what you need to understand is that the legs can be the same. For instance, a classic example of this might be that we could have a right isosceles triangle, where this side and this side are the same. Those still would be legs, and this longest side would still be the hypotenuse. Okay, so there's this relationship still exists for right triangles. Okay, now Pythagoras came up with a relationship, a mathematical relationship. He said, or figured out, that if you took one of the legs, okay, so if you took a leg, the value of that leg, and you squared it, and we'll call this the blue leg, and you took the other leg, we'll call this the red leg, and you squared that, that would be equal to the hypotenuse squared. So he figured this out, and you got to wonder, like, how much time did he spend working on this? Because, whew, buddy, that would have taken some time. But regardless, they figured it out. So we have since simplified this, and you're probably thinking, whew, thank goodness, because all them legs and hypotenuse starting to get a little confusing. And I would agree with you. So what we did is we said, hey, let's say we have this right triangle, and let's not just worry about it being an isosceles triangle right now, but let's just say that we have a general right triangle. Okay? We'll call one of the legs A. We'll call the other leg B. And the hypotenuse can be C. Now, C is always the hypotenuse, or longest side. C is always that. A and B, well, you can move them around if you want. You could park A there and you could park B there. It really doesn't matter which leg is A and which leg is B. It really doesn't. A and B. Historically speaking, if you do have legs that are different lengths, A would be the shortest, B would be the middle, and C the longest. But in the case of like an isosceles right triangle, you could have A, B, C, okay, and in this case, A and B would be the same value. And for those that love algebra, they might find my labeling here to be a little bit bothersome, but otherwise it doesn't matter. The legs just need to be labeled A and B to fit with this equation. And so what he figured out was this: that if you took A and you squared it, and you took B and you squared it, and you added those two things together, you would always get c squared. That's what he figured out. And that is very, very useful to us. So let's go ahead and see if we can't figure out how to make this work. And we'll apply this to a couple of examples. The first example, I'm not going to have you do on your own. We're going to do this one together. So example number 1, here we go. Example number 1, we're going to have a triangle where one side is 3, the other side is 4, and we don't know c. So what we're going to do is we're going to write our equation first. A squared plus b squared equals c squared. The next thing that we do is we plug in the values that we know. So 3 squared plus 4 squared equals c squared. Remember, we don't know what c is, so we just leave it. Now we simplify. 3 squared is 3 times 3. That's 9. Plus 4 squared. 4 times 4 is 16. And that equals c squared. Now, 9 plus 16 would be 25. So now you have 25 equals c squared. And you might be thinking, that still doesn't tell us what c is. We still don't know what it is. And you're absolutely right. But we can use some information about square roots that we had learned earlier. See, here's the thing that you need to know. If I had 2 squared, and I were to take the square root of that, that would give me 2. You might be thinking, whoa, Mr. Bornheimer, what did you just do? Well, follow along with me. If you take 2 squared and you turn it into 4, you would see that the square root of 4 is 2. And that is true. 2 times 2 equals 4. Now, let's apply this to this idea of c squared and 25. If I take the square root of c squared, just focus on that for a second. The square, so let me grab my laser pointer here. This square root symbol and this squared symbol, they cancel each other out. It's a beautiful thing. But the symbols cancel each other out. That's a huge idea here. So what we're going to do is we're going to take the square root of the other side. And that's because the golden rule of mathematics states that what I do to one side, I must do to the other. Okay. So square root of 25, the square root of c squared. This leaves us with c, and the square root of 25 is 5. And we've just solved this triangle like so. Let's do a quick off to the side here, just so that we can drive home a couple of the key ideas and skills that I just showed you. First of all, if you have 3 squared, and you take the square root of it, that will equal 3. If you take 5 squared, and you take the square root of that, that will equal 5. If you took x squared, and you took the square root of that, you would get x. And that is because the square root symbol and squares cancel each other out. They're opposites. And so you can see that we're left with 3 and 3, 5 and 5, x and x. Mathematically speaking, this also makes sense. If I took 2 and squared it, I'd get 4. So if I first square, then if I took the square root of 4, I would get 2. These are known as inverses. That means that they cancel each other out. If you square something and then take the square root, you're just undoing it. So if I take 7 and I square it, that'll equal 49. Then if I take the square root of 49, that will give me 7. I start and end with the same value. When I do both the square and the square root. So they are opposites. They cancel each other out. They cancel each other out. So in the case of over here, if I had the square root of c squared, the symbols cancel each other out, and I'm left with c. What I do to one side, I must do to the other. So if I take the square root of 25, I'm left with 5. Let's do another example here. I have a triangle. I have a triangle that I want to go ahead and solve for the hypotenuse. I know this side is 8 and this side is 15, and I don't know c. So again, first thing I do is a squared plus b squared equals c squared. I'm going to color code this for you. So 8 is going to be blue, and 15 is going to be red. So I'm going to go ahead and do 15 squared plus 8 squared equals c squared. Notice that the 15 and the 8, it doesn't matter whether they're a or b. They're both legs. Okay, so you have the leg side of the equation, and you have the hypotenuse side of the equation. 15 squared, okay, you should know this. 15 times 15, 225, plus 8 times 8 is 64, equals c squared. Now I have to add them together. Okay, so you should try doing some of this on paper if you can. 225 and 64, 9, 8, 2. So 289 equals c squared. Now, this is where that whole square root business gets into play. If I want to undo that squared right there, if I want to undo the fact that c is squared, I have to do the opposite of squaring, which is the square root. So I square root that side, and I square root that side, because what I do to one side, I must do to the other. This is the golden rule. This is very important. So first things that this does is it turns that into c. And we come over here to our calculator, and we do 289, and we take the square root, and we get 17. Now, you can't stop there. You have to go back to your triangle, and you plug it in. So this is a triangle that has the sides 8, 15, and 17. All right, last example, and I'm going to have you do this one on your own, and then we'll check it together. Example number 3, we have a baseball diamond, like so. And this baseball diamond has the infield. There's home plate, third base, second base, and first base. And I want you to notice that this is a square. And the distance between the bases is 90 feet on each side. And so the question that I want to know is, what is the distance between home plate and second base? What is that distance? So what is the distance between home plate and second base. Go ahead and try this on your own right now. All right. A quick hint, if you were stuck, okay, if you were stuck and you're having a hard time figuring out how to proceed with this, okay, I'm going to give you a quick hint right now, and that is that you're dealing with a triangle. If I guess I want to make it the exact same size as the diagram here. You're dealing with a triangle that is 90, 90, and you don't know C, the hypotenuse. Okay, so if you want to pause the video right now and try to figure this out now that I've redrawn it for you, that could be helpful. If you haven't paused the video, or if you've just unpaused the video, let's go ahead and proceed with this. The first thing that we do is we go a squared plus b squared equals c squared. We are going to go ahead and plug in our values here. So we have 90 squared plus 90 squared equals c squared. We're going to come over here and do 90. And we can hit the squared button, which would be 8100. Or we can just do 90 times 90, 8100. So we get 8100 plus 8100 equals c squared. This is going to, when we combine them, is going to give us a value of 16,200 equals c squared. And this is where that math of square roots comes in. We're going to take the square root of c squared and do the same thing to the other side because of the golden rule. What I do to one side, I must do to the other. That is extremely important. I can't square just one side, square root one side. I have to square root both. But that square root is a powerful thing because what it does is I don't want to say do's, but it undoes that square, and it leaves us with just c. Using our handy dandy calculator, 16,200, we take the square root, and we get approximately, this is where it gets tricky because this is not a whole number, we get approximately 127 feet. So the distance between home base here and second base is approximately 127 feet. That is example number 3. Okay. If you have any questions about this lesson, thanks for watching. Otherwise, you will have some homework assigned to go with it, and you can ask me questions about any of the problems that you encounter as you work through those problems. Thank you for watching, and I hope you have a great day.